So hi guys, welcome to the channel Learning Competitive Programming with CodeChef. So if you want to learn competitive programming and master data structures and algorithms, this is the prime location for you. Every week there will be several videos on the running challenges as well as the previous CodeChef problems. So please do subscribe the channel and turn on the bell notification. So myself Chirayu Jain, I am a CodeChef educator. I am from Jaipur Engineering College and Research Center. So the problem that we are taking today is positive AND with the code POSAND, and the problem is from October Long Challenge 2020. The prerequisites of the problem is done. So the agenda today for this particular video is, first we'll understand the problem statement with the help of examples, then we'll understand the approach of the problem with the help of examples, and finally we'll code the solution in C++. Okay guys, so let's understand the problem statement. So a permutation P1 till Pn of 1 till n. So we have been given a permutation from P1 till Pn. The values are from 1 to n is beautiful if Pi and Pi plus 1 is greater than 0. For every I that is ranging from 1 to n, you are given an integer n and your task is to construct a beautiful permutation of length n or determine that it's impossible. Right, so what we have been given in the question, that we have been given a permutation from 1 to n, and the permutation is considered beautiful if all the consecutive pairs of Pi which is ANDed with Pi plus 1 will result greater than 0. Right, so that is the important condition that is mentioned in the question. So if it is possible to construct a sequence, then we need to output that particular sequence. Otherwise, what will output that is impossible. Right. So A and B denotes the bitwise AND of A and B, right? So it is quite clear from the problem. So the input that we need to take is, the first line will contain the number of test cases, and then the test cases will follow an integer n. So for each and every test case we'll input an integer n. The output that we need to present is, for each test case output -1 if there is no suitable permutation. So if we are not able to get any permutation, that will output -1. Otherwise, what will output? Will output n integers in a single line which form the beautiful permutation. So if we are able to form the permutation, then we'll output that particular permutation. So if there are multiple answers, output any one of them. So if there are multiple answers for the given permutation, so if we are able to get multiple permutations possible with the specific condition, then what will output? Will output any one of them. So this is the problem statement. Okay, so now let us look at the constraints and the sample input and output of the particular problem. So n is ranging from 1 to 10 to the power 5, and the sum of n over all test cases does not exceed 10 to the power 6. Right, so these are the constraints of the problem. Subtask, we are given that for 50 points the value of n and t is ranging from 1 to 9, and for next 50 points we need to formulate the solution for the original constraints. Right. So for the sample input, we can see that the value of t is 3, and for each test case we are getting these n's, right? So for n equals to 4, the output is -1, right? Because we are not able to form any of the permutation. For n equals to 3, the output is 1, 3 and 2, right? So we can take the bitwise AND of these two numbers. So bitwise AND of 1 and 3 will result a value that is greater than 0. The bitwise AND of 3 and 2 will result a value that is greater than 0. So how we can calculate the bitwise AND? So we'll convert these numbers into binary, right? So the binary representation of 1 is this, the binary representation of 3 is this. So we'll bitwise AND it. So after performing the bitwise AND operation of these two numbers, what we'll get that is 0 and 1. So the bitwise AND of 1 and 3 is 1, that is greater than 0. So the bitwise AND of these two numbers and these two numbers is greater than 0. So this is the possible permutation. Similarly for 5, what will the possible permutation that we are getting is 2, 3, 1, 5, 4. You can check that every consecutive pair of integer is having the bitwise AND that is greater than 0. So these are the possible constraints and sample input and output of the problem. Okay, so let us understand the problem approach of positive AND. Right, so the condition that is mentioned in the question is that the bitwise AND of the consecutive numbers must be greater than 0. For any two consecutive numbers, we must have bitwise AND greater than 0. It is mentioned in the question. Now what are the observations that we can take out from the problem? First we need to clear out that what is the AND table. So If we have 2 bits, that is 0 and 0, the AND operation will result in 0. If we have 2 bits, that is 0 and 1, the AND operation will result in 0. If we have 2 bits, that is 1 and 0, the AND operation will result 0. And if we have 1 and 1, the AND operation will result to 1. So only if we have 2 bits set, then the AND operation will result 1, otherwise the AND operation will result 0. So this is the important thing that we need to first clear out before understanding the observation, right? So now let's move towards the observation. So we have 2 observations that are important in this particular problem. So the first observation is bitwise AND of 2 numbers of same length in binary can never be 0, right? So let us take an example to understand this point. So if we take 5 and 6, so what is the binary representation of 5? That is 1 0 1. And what is the binary representation of 6? That is 1 1 and 0, right? So if we perform bitwise AND operation on these 2 numbers, then what we'll have 1 0 0, right? So this particular pair of bits will result to 1, right? So this particular pair of bits will result to 1, and these two pairs will result to 0, right? So we took the numbers 5 and 6. The length of the binary length of both of these numbers is 3, right? So when will the binary length change? Whenever we introduce a new bit, right? So whenever we introduce a new bit in the binary conditions, then we'll increase the length, right? So we have seen that the binary length of these 2 numbers is same, and the result that we found is that it is the AND operation of these 2 numbers is greater than 0, right? So why this is so, right? Because the most significant bit of the binary numbers of same length is always 1, right? So we can take the example of 4 5 6, we can take the example of 4 5 6 and 7, right? So 4 is represented as 1 0 0, 5 is represented as 1 0 1, 6 is represented as 1 1 0, and 7 is represented as 1 1 1. So in all of these numbers, we can say that the binary length is 3, and the most significant bit of all of these number is 1, right? So whenever we'll perform AND operation to any of the consecutive pairs amongst these number, then we'll result the output as greater than 0, right? So we'll output a result which is greater than 0. Any 2 consecutive numbers we can take, right? But when this condition will not hold true whenever we introduce the new bit, right? So we have seen the condition, that is P1, and we have seen also practically that how this condition is true. So the condition is that bitwise AND of 2 numbers of same length in binary can never be 0, right? Because the most significant bit will be set in the same length, right? Most significant bit will be set, and any consecutive pair can never have AND 0. Okay, so what is the second condition that we are looking into is whenever a new bit is introduced in binary, then it makes the bitwise AND with the previous number as 0, right? So first thing that we need to clear out is when we are introducing a new bit, right? So we are introducing a new bit at the numbers like 2 4 8 16 32, right? So binary representation of 2 is 1 0, of 4 is 1 0 0, of 8 is 1 0 0 0, of 16 is 1 0 0 0 0, and of 32 is 1 0 0 0 0 0, right? So these are the binary representation. We can see the binary representation of 2 is of length 2, of 4 is of length 3, of 8 is of length 4, of 16 is of length 5, and of 32 is of length 6, right? So these are the things that we can see. So whenever we are introducing a new bit, the binary representation of this particular number and the previous number will result to the binary representation and of this number with the previous number will give the result as 0, right? So let us take an example. If we take the number, let us suppose we are taking the number 4, right? So 4, and we'll AND it with 3, right? So we'll AND it with 3. So the result of these 2 numbers will be 0, right? Because we cannot find a pair that is 1 1 in this particular number. So we can represent it like this also for the visual clarity. So we have not seen any pair that is 1 and 1, So the binary, so the AND of these two numbers will be 0, right? So we have seen these two conditions, right? So the first condition is quite simple to understand, that the same length number can never have the binary AND as 0, but when we introduce a new bit, right? So when we introduce a new bit, then only it will have AND 0 with its previous number, right? So if the number is 16, then it will have AND of the AND of 16 with 15 will result to 0. If we take 32, the AND of 32 with 31 will result to 0, right? So if we take 4, the AND of 4 and 3 will result to 0, right? So if we take 64, the AND of 64 and 63 will result to 0, right? So whenever a new bit is introduced in binary, the AND operation of that particular number with the previous number will result to 0. So these are the two important things that we found out in this particular problem. Now let's see how we can apply these observations to formulate our final result. Okay, so now let's carry out the approach further. So we have seen the observations 1 and observation 2. Now what we can draw the conclusion from this observation is that for the numbers in the power of 2, the AND with the previous number will result to 0, right? So we have seen that the numbers, when we are introducing a new bit, right? So the numbers will result to a power of 2. So the numbers with the power of 2 will have AND 0 with the previous number, right? So how we can resolve these conditions? We have found out the condition that when the two consecutive numbers will resulting 0 when they are ANDed together, right? So how we can resolve this particular condition is that if the ith number that we are taking is of the power 2, then what we can do, we can swap the ith number with the I plus 1th number, right? So why we are doing this, why we are using this particular condition, why we are swapping these two things is, so let us suppose that we are taking an example of 8. So 8 is of power of 2, right? So we have introduced a new bit in the binary representation that is at this particular position, right? So if we take the number that is previous to 8, that is 7, so the binary representation of 7 is 1 1 1 and this particular bit is 0. And if we take a number that is after 8, that is 9, so the binary representation of this will be 1 0 0 1, right? So we need to swap these particular numbers, because these two numbers, what they will have, they'll have AND operation as 0. The AND of these two numbers will result to 0. So we need to swap these two numbers. Why? Because in this particular example, what we can see that the lowest significant bit, that is this particular bit of 7 is set, and in this particular number, that is 9, the lowest significant bit is also set. Why? Because these two are odd numbers. The number after this particular number, that is the power of 2, this number is in the power of 2, so the number after it will be odd and the number before it will also be odd, right? So that means that the lowest significant bit, that is LSB of this number, will be set and LSB of this number will be set, because these two are odd numbers, right? So AND of these two numbers, that is the I minus 1 and I plus 1th number, will result to a number that is greater than 0. So we are confirm in that particular case, right? So AND of 7 and 9 will be greater than 0, right? And what we can do, we can place this number at this particular position. So what we can do, the final conclusion is that we'll swap the ith number and I plus 1th number, right? So whenever we found that a number is in the power of 2, so what the condition we can apply is, we can swap the ith number and I plus 1th number, and then the configuration is set and the resultant consecutive pairs will not have the binary AND as 0, right? So this is the important observation that we can draw from this particular problem. So what are the base conditions that we need to set in this problem? So the first base condition is that if n is equals to 1, right? So the value of n is 1, then the answer will return as 1. Will return the answer as 1, because this is the base condition, so we do not have any other number, right? So when this thing will terminate, when the result will be minus 1, that is impossible. So one thing that we can clear out is, we need to swap the number, that is ith number and I plus 1th number. We need to swap these two numbers. So what if the I plus 1th number is not present? There are possible conditions when the I plus 1th number will not be present. Let us suppose the example is 32. So 32 is itself, the value of n is 32. So 32 is itself in the power of 2, right? So we cannot take 33 because n only is 32. So we'll take the numbers from 1 to 32 in the particular series. So for this particular number 32 when ANDed with 31 will result to 0. So we need to swap 32 with 33, but 33 is not present because the value of n is 32. So in this particular case, we cannot have any configuration that will lead us that the consecutive numbers will result, the AND of the consecutive number will result greater than 0, because 32 will violate this particular condition, right? Because we cannot take 33 and we cannot swap 32 with 33, and 32 ANDed with 31 will result in 0, right? So whenever we are given n in the power of 2, then the answer will be -1. Otherwise, what we will do, we'll check for each and every pair, and then if the ith value is of the power of 2, then what we'll do, we'll swap it with I plus 1th value, right? So this is the possible case. So what is the base case? What is the base case that we can set? So the first base condition is that if n equals to 1, the output will be 1. Also for n, the value of n equal to 3, right? So till n equal to 3, so what is the possible configuration that we can take? So we cannot take 1 and 2 together, right? Because 1 and 2 will result in a pair that will lead us to AND 0, right? So we need to separate 1 and 2. So what are the possible things that we can have? That the possible configuration is 1 3 and 2 and 2 3 and 1. So these are the two possible configurations that we can have initially, right? So out of these two, can we take both of them? We can take both of them till n equal to 3, but let us suppose that if we increase the value of n equal to 4, right? So if we want to have n equal to 4 here, so if we introduce 4 over this particular first case, right? So 2 and 4 will result to 0 AND, right? So 2 and 4 when ANDed together will result to 0. So according to this condition, when 4 is introduced, because 4 is of power of 2, so what we will do, we'll swap it with 5, right? So we'll swap it with 5. So 5 comes at this particular position and 4 goes to at this position. So let's clear out the thing. So when we swap 4 and 5, so 5 comes here, 5 comes here and 4 goes there, right, after 5. So when we AND 2 and 5, the AND of these two numbers will also result to 0, right? So this particular condition violates over this particular case. And when we take the case of 2 3 and 1, so the AND operation of 4 and 1 will result to 0. But when we swap the number, that is 5 comes here and 4 goes after 5, so the AND operation of 1 and 5 will result to a value that is greater than 0, right? So what we need to take, the initial base condition is that if n equals to 1, what we will output 1, and for we'll take a vector and we'll input the values of the initial base condition, that is 2 3 and 1, so that we cannot get confused of 1 3 and 2 and 2 3 and 1, that if we enter 1 3 and 2, the condition violates over this particular case, and 2 3 and 1 taking the base condition as 2 3 and 1 in the vector, the condition fulfills, and we can take this whole particular condition of this particular logic by summarizing P1 and P2. We can take the whole condition forward for any value of n, right? So this is the particular approach of the problem. So now let's code this particular approach in C++. Okay, so now let's code the solution in C++. So first of all, we'll enter the test cases, right? And for each test case, we are given an n. So we'll make a variable n and we'll input it, right? Now what is the base case? That if n is equals to 1, if n is equals to 1, then what we'll output? We'll output 1. Other base case is that if n is of power 2, then what we'll output? We'll output -1. So how we can check that is n, if n is of power 2? So the simple condition is that what we'll do, we'll AND n with n minus 1, right? So if the AND of n and n minus 1 is resulting 0, that means that we have introduced a new bit, and the new bit is introduced when we are taking power of 2, right? So what we'll do, we'll AND n with n minus 1, and if the resultant is 0, that means it is of power 2 and will output -1. Otherwise, what we will do, we'll output the sequence. So first of all, we'll make a vector, right? And in the vector, what we'll have the base conditions ready, that is 2, 3 and 1. These are the base conditions we have understood in the approach, right? Now for I equal to 4, I less than equal to n, I plus plus, we'll input I in the sequence, right? Now the important condition that we need to check, that whether and n minus 1, the AND operation of n and n minus 1 is resulting 0. That means we need to swap the ith element with I plus 1th element, right? So for int I equals to 3, we'll check from I equals to 3, I less than n, I plus plus. What we'll check, that if v of I and v of I minus 1 is resulting 0, then what we will do, we'll swap v of I and v of I plus 1, right? So this is the condition that we have seen in the approach. And at last, what we will do, we'll output the whole sequence. So for I equals to 0, I less than n, I plus plus, we will output the whole sequence and we'll enter NL after that, right? So let's run this particular code on the given test cases. Okay, so we'll make else if over here, right? So for the given inputs, what we are getting is this particular output, right? So let's try to submit this code on CodeChef. Okay, so let's try to submit this code on CodeChef. So we are getting the correct answer, that is perfection sign AC. So we have seen the approach of this particular problem in C++.